Assalamu alaikum, dear all. I am Dr. Shafi Ullah from the Department of Civil Engineering at WA Engineering College, University of WA. The topic of my today's presentation is about the pavement structures and materials, which is actually about the road materials and road structures. It is a part of our bachelor program and master and also the PhD program, a subject which is called the transportation engineering and planning. In transportation engineering, actually we need to deal with two type of measures. One is about the transportation planning and management, and the other is about the pavement structures and materials. In transportation planning and management, we focus on that how to manage and plan the traffic and how to optimize the traffic flow in the city. While in the pavement engineering, we specifically need to deal with the pavement structures, that how the loads, the traffic loads are distributed in the pavement, and how the roads or the pavement helps us to carry these loads efficiently. So in this lecture, we will talk about that what is the recent status of pavement structures, especially in our country, Pakistan. What type of damages occur because of the traffic loading, as we know that with the passage of time the traffic is increasing, and also we have another thing which is the climate change, like the our rains, high temperature changes, and in Pakistan we specifically have the high temperature variations. So how can these factors affect the pavement structures, and what type of damages they induce in the pavement structures? So this lecture is about all these things, and I hope that our students who are in the bachelor or in the master or who are interested in doing PhD in pavement engineering, they will be benefited from this lecture. So in this lecture, I will talk about the recent status. What is the recent status? What are the gaps, and how can we develop based upon these gaps? So my report includes four contents. One is about the overview of engineering demand. Second one is the problem and what is the practical relevance. Third one is about the development of new materials and technologies. And fourth one is about the future vision. In the overview of engineering demand, we will little bit talk about the history of the roads, the transportation engineering. We see that if we compare the two things like the cars and roads, we see that with the passage of times, our cars have been developed so much. But in the other side, if we look at our roads are basically, I would say that no big advancement has been done in case of roads. If we talk about the vehicles or cars, uh, we see that even our cars have nowadays been developed with sensing technologies. They have specific type of sensors, but on the other hand, our roads are still the same roads. Like in the modern infrastructure, the modern transportation infrastructure believes that there should be a communication between the road and the car. So if we look at the present scenario, our cars have been developed so much, but our roads they don't have so much capacity that they could communicate with the vehicle. So the future research is basically based upon this concept, that how can we enable the road so that it could communicate with these vehicles. So there is a problem basically. This part, uh, the vehicle technology, the expert of this field have no knowledge about about these things. Well, the expert of these things, the roads, the pavement material, they don't have knowledge of these things. So basically, there is a gap between these two things. And in order to reduce this gap, to fill this gap, we need to collaborate with these peoples, and these people need to collaborate with these peoples. That is why in recent years, the researchers they state that there should be an interdisciplinary collaboration between the people so that they could understand the research interest or the gaps of other group people. So in our transportation engineering, these people, these are the people basically who are related to the computer science or the electrical engineering or data structure, that how to communicate the information from vehicles to the road. But these people, they have enough knowledge of the road structure, how to design a road, how to analyze the road structure for traffic loading, but they don't know how to the data which is generated from here to transmit this data to this thing, to create a communication between these two things. So basically there is a very large gap, and the future road believes in this thing, that if we need to develop cars, we also need to develop roads. So our lecture is about this thing, that how can we make our transform our road from traditional to smart roads. Smart roads will be the road that will have the capacity to communicate with the vehicles. They will have some real-time sensing functions. So in this lecture we will basically talk about that how can we make our road sensible. Like just like our human body, we have five senses. We can feel the change in temperature like hot, cold. We can see things, we can hear things, we have sensing properties. But our roads, our concrete materials, they don't have such type of functions. So, what is basically the problem, and what is the practical relevance? The problem basically generates from this thing, that we have a traditional model of road construction. Roads are subjected to traffic concentration and climate change, which is the most important factor nowadays. In Pakistan, we see that recently, because of the climate change, we have so many floods and the sudden floods. There are so many changes in the temperature uh, and very high temperature in the Pakistan. So all these things combinedly lead to these things, structure failure in the roads, and in turn we have very huge costs and losses. So the other thing is that there is a complex interaction between materials and the environment, that how the environment affects these materials, and how can it lead to these things, these failures. So first of all, we need to understand the interaction between the material and the environment, that how the temperature affects our road materials. So for this we need to do research, and a lot of research has been done by the researchers in the past. But what is the gap in this thing? The gap is here, that we don't have the advanced design and condition assessment approaches like this we hear. Like once the cracks appear in the road, the construction personnel come here and they do the condition assessment and they do some repairs. Like we don't have real-time condition assessment approaches. The reason is this thing, that our roads are made of materials that are inert materials. Inert means that they don't feel the they don't have any sensing properties, that they could give us some signals before the failure occurs, so that the damage at the premature stage could be detected and we can do some maintenance works. So what will be the consequences of these things? The consequences leads to it is difficult to calculate the journey time because of these delays, traffic delays. We cannot calculate the journey time, and also it leads to huge damage to the economy. Like we can see here, so many congested traffic because of only this thing. So in order to make this thing optimized, to make the traffic flow smooth, we need to do develop some technologies, because of which our road could communicate with the people in the cars, who are the drivers, who are the people who are traveling from one place to another place. So for this, so what are the basically, just like we talked about the condition assessment in the laboratory, if we look here, these are basically the developments in the laboratory work, that initially in the laboratory, this was the concept that we need to go to the laboratory and we took a core from the road or the mixers and we need to test it for the mechanical performance. After this came the CT scanning. It is basically X-ray. We took the sample, go to the laboratory and take it X-ray and then find the cracks. After this came the sensors. Uh, they need to put inserted in the roads, and they tell us about what is happening in the road. But all these technologies, these are the technologies which are externally applied to the roads. Like in sensors, sensor is basically not a part of the road. We need to insert a sensor in the road, although it acts like a veins in the body, but still it is not like a inherent part of the road structure. So people nowadays are focusing on this thing, like we see here. They are trying to make the concrete self as a self to act like a self sensors. They need to put some in materials component inside the control mixers, because of which the concrete will be able to feel the force, the humidity, and temperature changes, and in turn it will give a signal to the, just like a human mind, it will create some signals, and it will forward the signal to some operating and processing system, just like a human mind. Then after this, we need to process this data. So if I look here, this is basically in payment engineering. Recent studies only focus on this thing, which is basically a theoretical model. They model the payment for the climate change for traffic, which is basically theoretical. So we basically need to do this thing, that how the variation in temperature, the humidity, the freeze-thaw cycles leads to these things, which is basically called the real-time monitoring. That how can we measure the determine the deterioration of payments in real time, so that we could avoid these things. So in this, for this to solve this issue, we need to make a concrete like this, which could feel the traffic load, the climate change, and in turn it could provide some signals, so that the premature damage of such type of materials could be detected in real time, and in accordingly we could adopt some maintenance and repair technologies. So in case of our asphalt mixer, has like I told you, that we are basically in this lecture we will talk about the asphalt materials. This is the our asphalt concrete has a very heterogeneous composition, means that it is composed of different material. On one side we have aggregates, on the other we have asphalt or bitumen, and we have some filler, and we have some fibers, which are the additives. Among all these things, this thing is very uh, sensitive to the environmental variation. Like we see here, it's 60 degrees centigrade in 1 hour. Uh, this is its states. Well, at 25 degree for 1 hour it is like this, and for 10 hours it is like this. So this basically shows the temperature shift behavior of the asphalt binder. It shows that with the increase of temperature, how it changed its status. Like it is a viscoelastic material. Viscoelastic means that it at temperature, at a fixed temperature, sometimes it acts like a viscous material, and at the same time it acts like a elastic material. So it becomes very difficult to determine the behavior of this type of material. So in our pavement engineering, the whole attention is given to this thing, which is called the asphalt material. In many countries, the composition of this material have been modified, like in China, in developed countries, in China and some other countries, to avoid this behavior. But unfortunately, in our country, we are still using the same conventional asphalt, uh, which is incapable of uh, to withstand the recent temperature variation and traffic loading. So in this, in our asphalt concrete and in our asphalt material, the main attention is paid to this material and its behavior, that how it changes its internal condition with changes of temperature. And this is the only thing responsible for the deterioration of our pavements and our roads. So these are basically the function, that how our pavement structures responds to the traffic loading, to the thermal cycling. Just like I said that there are some factors which affect the performance of the roads, which first one is the thermal cycling, mechanical loads, and in some countries it is the freestyle cycle. In our country we have these two things normally. These type of things are occur in the cold or low temperature regions like China, Russia, and some other countries, Canada. So this is that how uh, uh, these traffic loads are transmitted in the pavement structure. Actually, the pavement is consists of many layers. The top layer is called the surface course, or the top layers asphalt concrete. Second one is the base course. Third one is the sub base, and the last one is the subgrade, or the natural, which is the natural crown. So this is that how pavement structure is affected by these things. This is the traffic loading we see here. These are the thermal cycling, and how it disturbs the distribution of aggregates, which is the granular structure. So this is how our pavement structure and its function uh, are affected by the thermal cycling, mechanical loads, and the freestyle cycle. So in order to understand the pavement structure and to analyze the stresses, strains, or some other type of things, we need to understand that how the stresses, whether they are due to the temperature, or due to mechanical loads or freeze the cycle, how they mechanistically disturb our pavement structures. So in our work, we are basically interested in the top layer, which is basically made up of the asphalt concrete, this one, the black top surface. If this surface is okay, so the underlayer surfaces are not so disturbed, because this is the main layer which responds to the traffic loading, which responds to the thermal cycling, and which responds to the freeze the cycles. So we should pay much attention to the to strengthening this layer, so that if this layer is okay, if this layer effectively distributed the loads, the underlying layers will perform and will function smoothly. So this is that uh, how the durability and serviceability of asphalt pavements gradually deteriorates with time. For example, this is the vehicle. These are the stresses, strain imposed because of the loading and unloading, and how this leads to such type of stresses. This is the rutting which normally occurs in Pakistan. We see on the roads. It occurs because of the high temperature. These are the cracks. These normally occur in the low temperature regions, and also in the Pakistan. These are the fatigue cracks. Fatigue cracks mean that they occur because of the constant loading, and these are the moisture damages. In Pakistan, we also have this damage, but compared to this one, we frequently see this type of damages on the road. These type of damages normally occur in China, where 75% part of the China is exposed to the large temperature variation. There are so much rains. So these are basically the general failure modes that occur in the pavement structure because of the environmental condition, because of the traffic loading. So this is that uh, like this how this relaxation means that during loading and loading, how this leads to gradual aging of the pavement. These are the environmental changes because of the changes in temperature, and how they collectively lead to the distress in the pavement structures. So in order to know that, for example, if you want to do some research, conduct a study, whether it is a practical study or in the laboratory, we need to know that what is the reasons of, for example, the rutting, cracking, fatigue cracking, and moisture damage. And in according to these things, we then need to apply the same methodology to assess the behavior of these things. So in avoid to, uh, as I discussed that the pyramid structure is subjected to this type of damages. So how can we overcome these things. What we need to do next, that these are the problems we see from a very long time on our roads, that our roads are subjected to traffic, to environmental changes. So how can we reduce these things? So for this thing, we need to adopt a new construction philosophy. A new road construction philosophy is needed. Why we need to new construction? Because of this thing, as I told you, this bitumen or asphalt, it is even inferior to simple polymers with regard to its thermal and mechanical properties. Just like I discussed in the previous lecture, or asphalt or bitumen, uh, in Pakistan we normally use the neat bitumen, which comes from the Atak refinery or some other. It is a petroleum based. So this neat or virgin asphalt matter, it is even inferior to the polymer. In China, people are using the plastic or SPS, which is a specific type of polymer. They put it in the asphalt binder. They modify the internal composition, and they make it to like this to meet these service requirements. So in our country, we should also pay attention to this thing. For example, if people in the transportation and pavement engineering want to do research, so they can also uh, modify this thing, to add some polymers, plastic, or some other thing, so that its mechanical and thermal performance can be improved in comparison to the conventional asphalt binder. So how can we develop new materials? Like for example, our asphalt, it is a very weak in the resistance to the temperature and thermal stresses and mechanical loads. So what we need to do, now we need to develop new materials based upon these things. Development of new materials, which I did in my work in my PhD, which was a part of my PhD research. What I did to avoid these things, these cracks, these rutting, these water damages, what I did, I modified the composition of the conventional mixers. I added some type of conductive additives in the asphalt mixer, and what I did, I created a piezo-resistive behavior to enable self-monitoring of the material. This type of mixers were different from the conventional mixer because conventional mixer just gave me the mechanical performance. But this type of mixers, when I added some fibers and conductive additives added in the conventional mixer, so I modified its internal composition. So what this type of mixer performed for me? In addition to the mechanical performance, it also gives me information about its internal composition through changes in electrical resistance, which is basically called the term FCR. FCR is basically denotes the fractional changes in electrical resistance, which was a measure of the self-monitoring performance of the asphalt concrete. So in my work, I went from conventional mixer to a mixer which was basically acting like a sensor of its own condition. Like I went from conventional to smart smart technique, like which was basically the inherent sensing properties of the mixer. So what was the problem? What I did this problem statement was this thing, that in asphalt pavements expose early damage during their surface life. This early damage cannot be detected uh, with the naked eyes using any type of sensing technology. We cannot detect this early damage, and this early damage basically uh, generates uh, between due to gaps inside the aggregates. Like for example, when the pavement is subjected to traffic loading, so because of the loading and unloading, just like I said in the previous slide, that relaxation, these relaxation and these loading and unloading, they lead to early damages, and this early damage actually with the passage of time accumulates within the pavement structure, and then with the passage of time it appears in the form of a macro damage, which is called the visible or obvious damage on the pavement structure. So what was the challenges for me? How to enable real-time monitoring of damage evolution in asphalt concrete? So there were basically two prerequisites for me. One was the that how can I develop a optimized conductive mix composition, and second was that how can I impart self-sensing functionality in this concrete. So this thing was basically the most challenging thing for me. That first of all I added some conductive additives in the mixer. I use different type of compositions, but to optimize the composition was the very difficult job. Optimization means that it should give me the optimized properties in terms of both the mechanical and the electrical properties. Sometimes when we put additives, they negatively affect the mechanical performance, although they increase the electrical properties of the material. So in my case, I think this is the most challenging the job, that how can we get the optimized conductive mix composition. Once this composition is achieved, this thing becomes possible. So this was the basically idea that uh, that how I modified the mixer composition. This is the conventional mixers. These are the aggregates. These are the voids or spaces, and the or asphalt binder is basically here. So what I did, I put fibers. These red type of these red shows basically the fibers, carbon fibers. So it basically uh, reinforced the mixers. So what it did for me, when I applied loading and there was some cracks generating in the mixer, so these fibers basically reinforced this crack. So this basically this I applied tensile loading. When again on in the another experiment, when I applied the compressive loading like this, these cracks were recovered like this. We see that in a pavement engineering, for example, this is the tire. So there are basically two type of one is this is the tension, and this is the uh, tension, and this is basically the compression. So for example, on one case, if the mixer is subjected to tensile loading, on the other on the same time it is also subjected to the compressive loading. So these fibers, in this stage, these fibers acts like a reinforcing materials. They reinforce the mixer within. So basically it acts like a smart and better structural material which prevents its own damage through fiber bridging effect, and reports the change in its internal composition through corresponding changes in electrical resistance, thereby providing early damage identifications, which was basically the problem. Just like in previous slide, I told here that it is difficult to detect the early damage in the pavement. So by using this general approach, by changing the composition of the conventional mixers, one thing was this that I improved the mechanical performance of this mixers. Mechanical performance means that I I improved its cracking resistance, and the other thing was that it gave me these two properties to prevent its own damage, and also it gives me some sensing capability through which the mixers give indication about the changes in its internal composition. So the my work was about this thing, that how uh, we can uh, change the composition of the mixers. How can we grow from the conventional approaches to new sensing, new that are sustainable, which are resilient. If we look here, this here the mixer is sustainable. Sustainable means that it maintains its own structure even if it is subjected to the applied loading. So our recent research or our recent demand is this thing, that our road structure should be sustainable. So if we go from this thing to this thing, it means that we can achieve the sustainability of road infrastructure. So what is the future vision using these concepts? the self-sensing or self-monitoring concept, that if the mixture has a self-sensing properties, it can detect its own damage, it can give information about its internal structures damages. So how can this contributes to our future in the transportation engineering? So they are basically there. We need to here link two visions. One is about the that we need to prepare surface layers with optimal performance characteristics and long service life. This is the main thing. Just like I talked in the that this thing was the most difficult to achieve, to give us a properties that are uh, the properties that are best in terms of the mechanical performance and in the electrical performance. And how can these lead to longer service life? Longer service life is this thing that the road material or the mixture should be sustainable, resilient. It means that even if it is subjective to damage, with the passage of time, it will have the capacity to even recover from the same damage. So this was the first vision. Second vision was this thing, that here we need to link this thing with this thing. Information increase with regard to drivers and traffic control as the infrastructural basis for automated driving. So this thing basically helps us in achieving the automated driving. That how can because if you look on the recent advancements developments, that the roads have no sensing capability. Even if we put sensor in the vehicles or in the cars, they can be very sensitive to the environmental changes and these things. But on the other hand, our road is have no sensing properties. So by imparting the self-sensing behavior, self-sensing properties in the road, this thing can be realized. And for this, our route should be the sensitive and materially optimized. Sensitive means that it should act like a sensor. It should interact with the vehicles. And second, this thing will be the most important. It will be materially optimized. Optimized. It means that it will have a longer service life. So this is the basically the future concept on which the people are focusing. That how can we change the roads from conventional to other roads, which which could give us some generate some revenues in addition to just carrying the traffic load. We all know that our roads are used for carrying the traffic load, and we have not seen any other advantages that we have got from the roads. Although roads cover a large area of a country or a city uh, in every country. So this is basically these can be the research fields for the new concept of roads. First one will be the structural engineering, that how can we improve the structural performance of the road. Second can be the detection, that how can it helps and helps us in the structural health monitoring or traffic monitoring. Third can be the communication, that how can it helps us to develop a communication between the road and the vehicle. And the last one can be the energy conversion or energy harvesting. In many countries, people have worked on this thing, in Japan, in China too, and in another developed countries, people are getting, researchers are getting energy from the roads. This communication is also okay in some countries, but it is only limited to the people in the electrical engineering, data structures, and computer science. They know how to enable communication on the road, but they are basically unfamiliar with these things. That the main thing is here, how the traffic loads are distributed from here to here, and how actually uh, the behavior here of the road. So for this thing, what we are doing in our work, we make this layer sensitive surface layer. This layer will act like a sensor itself. So what damages occur here because of these things here? These all these variation transmission of these stresses strains. This will be shows to us like this in terms of some signals. Like here is the vehicle. If it goes on the roads like this thing, so it will generate some signals. So this signal will be transmitted from this place to like this, that it will helps us in the traffic detection. Like we will be able to detect the traffic, that what was the speed of the vehicle, what was the weight of the vehicle. So even it also helps us in the that we can measure the weight of this vehicle in real time. I think in our country, in Pakistan, there is no such technology that we could weigh the vehicles or motors that are moving on the roads. they, there is some measurements, but these are all the statics. In these dynamic situations, we don't have any technique because of which we could measure the weight of the vehicle, and it could provide us some information about the vehicle. So our this work is basically the smart sensing or self-monitoring. It will enable us to measure the traffic flow, traffic flow, and also to determine that what is happening inside the pavement structure because of this traffic loading. So this is basically the way that how can the information from here can be transmitted to these people. In this, we need first of all need to develop new conductive materials. Testing of self-monitoring asphalt under diverse conditions. Diverse mean that it should include both. It should include traffic loading and environmental condition also. That how the road is affected because of the climate change. For this, we need to do field testing. We need to collect data, and then we can perform the real-time monitoring analysis. This is the generic or the view of that how a vehicle comes on the roads. So how the data, for example, from here the road, there will be interaction between the road and the vehicle. The data will be collected first of all by the multimeter. Then it will be transmitted to the transmitting antenna. From here it will go to the data center, and then here it will decide that uh, how can we use this data for the traffic monitoring and for the structural health monitoring. Here we need to identify some thresholds, like traffic speed. We should say that the traffic should speed should be between 40 to 60 kilometer per hour or something like this. Even now, if this vehicle speed exceeds 60, so it means that here we will get the signals, and these signals here, this signal will be transmitted to this thing. So in this case, this is the concept that how can we use the smart sensing or the ability, smart intrinsic ability of the road to make the traffic flow smooth. How can we enable the roads to detect their own damage, and how can we go from conventional methods to sustainable and resilient methods that could help us in developing a smart and sustainable road infrastructures. So as I told earlier, that here is the still gap. For example, the transportation payment engineers, they have a very good idea of these things, that how the stresses are transmitted because of the vehicle, because of the sun and other things, but they have very small idea of these things because they don't know the data science, data structures, these using how to transmit signals and how to optimize these signals. But on the other side, the people from the data science, they know these things. They simulate these things using their own concept. So they transmit the data from these are the RCU, roadside unit, ABC. So from different vehicles they collect the data here. From here data, and from here it goes to cloud. So but they have a very good knowledge of these things. Even nowadays people are using like there is a new technology which is called edge computing. Edge computing edge computing means that the processing of the data will be done at the edge of the road. it will not be transmitted to the cloud. So this is a new technology which is basically utilizes the WANET. WANET is basically vehicular uh, networking. That how can we transmit the data from car to the road edge, and so that the data is transmitted here instead of going to the clouds, because if the data is transmitted from here to the clouds, it will take a long time in the processing, so the response from the data center will be very low, so it will affect the communication between the vehicle, between the road and the people here in these vehicles. So there is this is a new technology, but the thing is that we need to reduce the gap between the people here and the people here, so that our transportation infrastructure or our roads could be efficiently utilized for these properties, for structural health monitoring, for traffic monitoring. So uh, lecture in this lecture, uh, these are the gaps, these are the things that upon which we can develop new knowledge, new techniques, and how can we use these shortcomings to develop new sensing technology, new roads, and how can we further this research in our master or in bachelor or in PhD. But there are also some drawbacks or limitations of these things. This includes that what will be the durability of this material in real world applications. Second one is this, that how can the integration of integrating challenging with the existing infrastructure. Either we need to develop a new infrastructure, or we can we can insert our these techniques in already existing infrastructure, because our existing infrastructure is in critical stages, and we don't know, we have no very good technology that we could determine this criticality of these infrastructures. After this, we have deployment, scalability, and cost. So these are the issues. And in addition to these things, we have electrodes and wiring systems. That how can we do this thing, and whether they will be affected by the environmental disturbance, and how can we process these signals which will be generated by the vehicles and will be collected by the multimeter and will be transmitted to the data center. So these are basically the some type of risks. So these are also some gaps. We can work on these things to mitigate these risks and these problems. So what can we do for these things? For this, we need to do the extensive lab testing and iterative refinement of based on the results. That the results which we get, we can optimize these results. And for this, we need to collaboration with the industry partner for practical implementation of these insights. So the knowledge which we talk about, like what can we do, uh, we give our own idea, but there may be some challenges which we discuss, like deployment, scalability, cost, how can we process the signals. And for this, we can do the extensive lab testing, we can refine the results. And for this, we need to do some collaboration with the industry. So these are all the gaps that upon which we can develop new knowledge. We can get new results. Maybe the results are good or not, but still uh, we can get some idea that what is happening. So in my view, uh, based upon my previous experience, these are the some gaps which I concisely and shortly presented in some slides for you. So the students who are in bachelor or in master, are those who are doing PhD, so we can start some work on this thing or do some collaboration. And I hope this lecture will be very useful for you people, because if we compare these things with the conventional things, we can get much, you people can get much knowledge that what is actually happening and what needs to be, because in our country, or for every people who are the early career researchers, they are in the search of that how to find a gap for their study. from where we can start the study. So I hope that and I believe that this lecture will help you people a lot. And, thank you. And I am from Goa Engineering College. If you need any assistance in any help, you need to make an idea, refine your idea. So you people can contact me. Thank you very much.